Alrighty, for example 2, we're going to see how we can combine like terms based on what we know about the distributive property. Okay, so oftentimes you can say, hey, like terms is something that has the same variable and the same exponent, but we never really understand why. Here's why. So if you can see here, 17a and 21a both have a common factor of a. So I can kind of like take a out of that expression, like this, and leave 17 plus 21 in the parentheses. So kind of squeezing out a is a process called factoring. It's like the opposite of distributive property, right? You take the common factor and then extract it from all the terms that have the same factor. So, how does this make sense, right? If I like distributed a for each of those, it will go back to the original expression. So factoring is that, and once I have that set up, I can just add these guys together, and that is going to give me 38a. Right? So that's the reason why we combine like terms, is because I can extract the common factor a from 17 and 21 because they both have it there. Okay, and that's why we can combine them together. So let's look at a more concrete example. So you have 12b squared minus 8b squared plus 6b. So if I look at them closely, I only see that 12b squared and 8b squared have a common factor, right? 6b is not a common factor because it needs to have a exponent of 2. So if I combine these together, right, I have 12 minus 8 in the parentheses, and then I know they're both being multiplied by b squared, 6b. I can simplify that together. 12 minus 8 is 4b squared plus 6b. Alright, and then that is the simplest form because these are the simplest factors. Okay. So, like terms in general, if you want to find the shortcut, is this. Okay. Combining like terms is adding and subtracting the coefficients that have the same variable, right? So the same variable like x, and then the same power like squared. Okay. So let me give you an example with some terms. So like terms here, as you can see here, I have 3a squared plus 2a squared. They both have the same variable and the same exponent. So therefore, I could just do 3 plus 5 gives me 5a squared. Same thing with 6b minus 5b. 6 minus 5 gives me 1b. And then this one is like term technically because they don't have any variables. So they can just be added across like that. Not like terms. So if you look closely, this has a x squared, but this one does not. Okay, so that doesn't work. And then this right here, they might have the same exponent, right? But this is the x and this is a y, so that doesn't work as well. They need to have the same variable and the same power in order to add and subtract the coefficients across. Alright, so remember this little rule, and then try these problems right here. All right. Go for it.